As we said before, pipes are formed by the pipe body itself and the connections. Now that we have understood what the pipe body is, let's see what a connection is and which the different type of connections are according to the different applications. Basically, a connection is a mechanical assembly that joins two or more pipes together to form a string. The connections are mainly related to threads, and all the connections in OCTG pipes have a pin and a box. But why is a connection necessary? If we had one single and continuous pipe long enough to reach the required depth of the well from the surface, there would be no need for connections. However, due to practical restrictions and manufacturing limitations, the pipes must be produced in a specific length range, and those pipes must be made up together through connections. The connections must meet different requirements such as structural integrity, sealability response, clearance, and some mechanism to prevent the back-off to avoid the separation of the pipes connected in the string. Before analyzing the different type of connections, allow me to give you some basic concepts and definitions. Thread profile is the shape of the thread itself. Metal seal is the area of high pressure contact between the pin and the box that provides sealability, that is, it prevents gas leaks. Shoulder is the area inside the box where the nose of the pin touches it and is in full contact with it. Outside diameter is the external diameter of the connection. This diameter usually is different from the external pipe of the pipe body. Efficiency is the relation between the connection performance and the pipe body performance multiplied by 100, as the efficiency is expressed in percentage. The connections together with the pipes behave like the links in a chain. The performance of the connection is related to its tension, compression, internal pressure, that is burst, external pressure, which is collapse, and torque. When we say that a connection is more than 100% efficient in tension, we are stating that the connection has a tension performance that is higher than the pipe bodies. If we pull out such string, the pipe body will break, but the connection will remain intact. On the other hand, when a connection is less than 100% efficient in tension, then the pipe body is more resistant than the connection. Therefore, the connection is the weakest point of the string, and if we pull out such string, the connection will break. The thread profile has different characteristics, such as load flank, which is the one that supports the weight of the string, the stabbing flank, which is required to allow the pin enter to the box in a smooth way, and the crest and root, which are the heights and valleys of the threads. And now, what do you think? How is the sealability assured by a connection? And the answer is through the seal interference. But what is seal interference? The connections are manufactured in such a way that the outside diameter of the pin is a little bit bigger than the internal diameter of the box. When both parts are made up together, they deform elastically until a balance is reached. The pin is shrunk and the box is expanded. These deformations are always within the elastic limits. That means when the connection is broken out, both pin and box recover their original shape. Such deformations never reach plasticity. At this point, we can say that the interference has been reached and the metal-to-metal contact pressure has increased to promote sealability. Another characteristic of the threads is the taper. This represents the change of the thread diameter in a given length. If D1 is the smallest diameter of the thread, D2 is the biggest diameter of the thread, and L is the length of the thread, then we can say that taper is the diameter variation divided by length times 100. That is, taper is equal to D2 minus D1 divided by L times 100. Let's see this with an example. If D1 is equal to 6 inches, D2 is equal to 7 inches, and L is 16 inches, then the taper is D2 minus D1 divided by L times 100, that is 7 minus 6 divided by 16 times 100, giving a result of 6.25%. Continue with the thread characteristics. Another parameter is the standoff. But to better understand this concept, we need to explain first what the hand-tight and the power-tight positions are. When we make up the connection by hand until the external surface of the pin comes into contact with the internal surface of the box, we have what is known as the hand-tight position. Let's identify the distance from the nose of the pin to the center of the box with the letter A. If we continue making up the same connection with the power tongue until the required torque is achieved, we will reach what is known as the power-tight position. And following the same nomenclature, we can identify this new distance from the nose of the pin to the center of the box with the letter B. Then the standoff is defined as the difference between A and B. There are different types of connections. The first connections used in the oil and gas industry follow the API standards, particularly the API Spec 5B, titled Specification for Threading, Gauging, and Thread Inspection of Casing of Tubing and Line Pipe Threads. These connections are known as API connections, and according to the profile of their threads, they may be round thread or buttress. As these API connections are from the public domain, any API qualified mill can manufacture them. Over time, following the increasingly complicated environments in the oil and gas industry, the drilling operation became harder and more complex. Today, wells tend to be deep, deviated or horizontal, multilateral, more demanding in terms of high pressure, high temperature, corrosiveness. And the connection had to be able to follow all those new challenges. For this reason, pipes manufacturers began to design new connections that exceeded the API requirements. And those new designs belong to each manufacturer, and they are known as premium connections. Premium connections are proprietary, meaning that each manufacturer has its own designs, intellectual property rights, and product exclusivity. Just as a comment, bear in mind that premium connections as well as proprietary steel grades concentrate most of the R&D activities of the modern oil and gas industry, developing new products for sophisticated applications such as extended reach wells, drilling with casing, steam-assisted gravity drainage, shales, deep and ultra-deep wells, and so on. to compare the behavior of this huge amount of new premium connections, API initially published the API RP5C5 titled Recommended Practice for Evaluation Procedures for Casing and Tubing Connections. Later in 2002, the international standard ISO 13679 Petroleum and Gas Industry Procedure for Testing Casing and Tubing Connections appeared, and this is today the most utilized standard to qualify premium connections. And finally, there is another type of connections for some specific applications known as connectors. Summarizing, based on all the above, we can characterize the full family of connections are belonging to API, premium, and connectors. Then, API connections can be either round thread or buttress, and on the other hand, premium connection can be threaded and coupled or integral, with integral being those connections where the pin and the box are threaded on the same pipe, and there is no need for any coupling to join two pipes together. The integral connections can be classified as flush, semi-flush or near flush, and upset. Let's see the main difference among all these connections.